Welcome to the lesson 18 of the C programming language. In this video, we will study for loop present in C language. Why do we require for loops or any kind of loop? Whenever we want to execute some set of statements more than once or a number of times, then loops are usually required. So what is the plan? So first we will see the syntax. Okay, then most common use case. Then we'll discuss a bit about loop variable, test expression, other statements, etc. Then what is loop body? Then scope of loop variables. Then a break, which is important keyword used in loops, and continue, and the nesting of for loops, and few working programs. The syntax, the basic syntax, this is syntax for is a keyword. Okay, then initialization, this is the common syntax which we are discussing as of now. Then some test expression and the statements. So usually these statements are nothing but increment and decrement of loop variable and initialization. Okay, so what happens is, and this is the within the pair of braces, whatever legal statements you would like to write, you can. So initialization step is done only once. So normally we initialize here some variables which control the number of times the loop would be executed. Then after initialization, this step, it tests the expression. So this initialization is done only once. Then the test expression, and if this expression evaluates to true, then only it proceeds to execute these statements which are written inside the pair of braces. If you want to execute only one statement, it is not essential to have pair of braces, as I have told number of times in the previous videos. After finishing the execution of these statements, it goes to these statements, and here they are normally increment or decrement statements which control or which may change the value of the test expression. So after executing these statements, it goes back to this test expression. So I repeat, it starts here, then after this it comes here, and if it is true, then it comes here. If it is false, it will come outside this for loop. Okay, and if it is true, it executes this, and after this it goes back to the third element, that is, it executes these statements. After finishing execution of these statements, it comes back to test expression. If it is again found true, it will enter, otherwise it will exit from here and it will exit the loop. So these things, this one is known as a loop head, FOR, and within the parenthesis initialization, then semicolon, test expression, semicolon, statement. And whatever you write within pair of braces, it is referred to as loop body. So this is the loop body. For is a keyword, and remember here FOR, this is essential, opening parenthesis essential, this semicolon is essential, semicolon is essential, and this closing parenthesis. These elements are essential. Initialization is optional, test expression is optional, these statements are also optional, and these statements are also optional. If the body is missing, then you need to terminate this for loop by making use of a single semicolon. Now the most common use case. So on the left hand side you see I have declared one variable of type integer, assigned a value 0, initialized. So this is the initialization phase. Then the test expression. Okay, so I less than 5, is it true? Yes, it is. So it executes this statement. So it will print OK once and other statements if you have written any statements here. And after finishing that, it will come to this. So I plus plus, the value of I becomes 1. Then again it tests. It is still less than 5. It will again enter the loop and so on. So how many times it is supposed to execute these loops? This loop? Five times. For once for I equal to 0, then 1, 2, 3, 4. As soon as I becomes 5, this condition fails or it evaluates to false, so it terminates the loop. It does not enter the loop again. Few properties. Loop head, we know what is the loop head. This one. This is the head of the loop. Loop variable, I is referred to as loop variable because it controls, it takes active part in controlling the number of times loop is to be executed. So this is loop variable. Here loop variable is I. Test expression, this is the test expression. Okay, then increment decrement statement. So here I have written increment statement. Okay, remember there is no relation among these three elements, head elements. It can be anything. Loop variable may be I, but test expression may not contain I, and increment decrement may be incrementing decrementing something else. But practically in most common uses, this is the situation. Loop variable takes part in expression, test expression, and it gets incremented or decremented. This is the most general use. The scope of loop variables. So if you declare this I inside the parenthesis, it means loop head. So this loop variable is accessible only from within the loop body. So it is accessible here only. So if I have written like this, and if I want to print the value of I, this would be syntax error because I has not been declared. It has been found to be not declared. So this I, but now there is a situation that which we'll cover in some other video, that if a variable before for loop I have declared, that I with name I, that I would be accessible here. So scope of loop variables is the loop body. So this I at least is accessible or relevant inside this loop body only. A pair of braces makes a scope. Remember, anywhere I can make use of, anywhere in the code, if I make use of this pair of braces, opening brace and closing brace, it makes a scope. It need not to be attached with any for loop or while loop or function definition or so. Okay, any variables, as I told you, any variables declared inside the loop body are local to the body. Before printf or after printf, I can declare another variable and I can initialize, I can make use of it. But outside this body of the for loop, that variable is gone. It means it is local to the body. Now break. So this is one typical usage. How many times printf is supposed to be printed? 5 times. We have seen. So after this you may have some statements, then break keyword, break is a keyword, and then other statement and so on. So as soon as break is encountered, the loop is broken from this point itself. Suppose after execution of some statements, if it happens to be executed, the loop is terminated and the system comes out of the for loop. So break is a keyword, breaks the loop at that point where it has been executed. Loop breaks if break is executed or the test expression fails. So this loop, this for loop would be broken if and only if either of the two conditions is satisfied. That is, this test expression fails, that is it evaluates to false, then loop would not be broken, I will say. It will not enter at all. Okay, it will not enter if the test expression fails. And loop is broken if the break is executed. Remember, in case of nesting itself, this will be important. The break breaks only that loop inside which it has been executed. So it may so happen that this for loop has another for loop as one of these statements. Then if this break is executed outside the inner for loop will not be broken. Outer for loop will be broken. Okay, so break breaks the loop, that loop only inside which it has been executed. Then continue. Okay, so the same example, printf continue. As soon as continue is executed, what happens is all statements following continue would be skipped, and continue would, you can say, jump to the third. So all statements following continue would be skipped if continue is executed. So again, few properties: continue is a keyword, and this skips the remaining body of the loop and continues with the third element of the head. So this is the third element. Okay. Continue affects only that loop inside which it is executed, just like break. So if you have a for loop inside a for loop, and if this continue is executed inside the inner loop, then it will continue with the third element of the head of the inner loop. So it affects that loop only inside which it has been executed. Now nesting. So you can have a for loop inside a for loop. Okay, inside which you can have another for loop, inside which you can have another for loop. So this is the loop head, this is the body. So this is the body of outermost for loop, and this would be the body of inner for loop, and this is the body of innermost for loop. Okay, and there is no limit on depth of nesting. How many for loops you can have one inside one another? There is no limit. So now let us have some working programs. I have written 3 programs, perhaps. I don't remember, 2-3 programs. So let us see. So first program is on the left hand side. You will find, I will execute it. Smallest for loop. Now you can see here, as I told you, nothing is essential in case of a for loop. So this is the smallest for loop which you can encounter, though it may not be having any use of it, but sometimes we make use of it to delay the things. Okay, it is an infinite loop, and here no initialization, no test expression, no increment decrement statements. Okay, but since for is a statement, it has to terminate in a semicolon. So this is a statement terminator. Okay, so this is the smallest for loop, smallest possible for loop, but this is an infinite loop. This will never be broken. Okay, so how to come out of it? It will depend on the system. So I am using Linux operating system. So here I have to press Ctrl C. It will come. It will rather break the or abort the program itself. Ctrl C. Okay. Now let me come out of this program and let me load another program for infinite. Okay, on the left pane I will execute it, for infinite. Now here what I'm trying to do is, this is also an infinite loop. Okay, for semicolon semicolon, but here this time it has the body from this semicolon up brace, opening brace, to this closing brace. So this is the body of the loop. What am I expecting here? I'm just printing one one prompt. Okay, type in an integer, scanf. Okay, now if vel equal to 0, break the loop. It means stop the program, come out of this loop and says return. Otherwise print the value of vel. Now earlier in older compilers, older versions of C program, programming language, here initialization used to be done with the arbitrary value, because I have not initialized it. But later versions, by default, it initializes it to 0. Okay, it initializes it to 0. So if you type something which is not an integer, okay, then let's see what happens. So first of all, I will type maybe some 4. You can see it is in an infinite loop. 6. Now if I provide 0, it breaks the loop. Let me execute it once again. Now this time I will say 5.6. You can see infinite loop. It has entered into infinite loop. What has happened is it is trying to read. So it has printed 5. Okay, it is printing 5 because I provided the value. What? Control C I will press. Let me run once again. 4.5. So it has printed 4 and then it is finding 0.5 a point in the input stream, or you can say buffer associated with the keyboard. Scanf would read from a standard input for a device, that is keyboard. So as I told you in one of the previous videos, that if the provided value type of the value data type of the data is different from type of the data expected, then the buffer is not clear. So it is assuming that you have already typed something, but it is not matching. So it is not clearing the buffer. So it is not stopping. So it will keep on executing. It has entered into an infinite loop. So the only way is to press Ctrl C. It means here you have to provide exactly integer, no floating point number. Let us play with this by providing some R. Type in an integer R, because what is happening is in modern C language, what is happening, if you have read something, okay, if it could assign the value, proper value, then the value of this val you can find out. Otherwise it will assign a value 0 to this val, so it will break. So if you provide something, let me again execute some symbol, it is also not an integer, so it will initialize val to 0 and it will break the loop. It has not printed. Got it? Okay. So now let me load another program, infinite, after infinite, for what is the use of continue. This is the source code, and here I will say for continue. Again a similar program, again it is an infinite loop, okay, and here again I am using printf. Type in an integer int success equal to scanf. What scanf does is, how many elements it has read, it returns that value. So this success would be given the value 0 if it has not read anything, if it could not assign. Less than 0, it means some negative number if there was an error in reading, and greater than 0 if it reads successfully the values and assigns them to various variables which we supply. Here it is only one variable. Okay, so if it is successful, if scanf has assigned an integer, then we will proceed further. Otherwise, if it returns some value which is less than or equal to 0, it means it has not read an integer, then getchar. What getchar does is, it reads one character from, or one byte from the standard input device, that is stdin, which is nothing but the keyboard, and then it says continue. It means whatever you have provided at the input, it will keep on reading it, because this is the infinite loop. So if it encounters anything which is not digit, it means this scanf could not read successfully the integer. It will keep on reading and not storing it anywhere, and continue. It means it will skip remaining statements, and this continue will come back to this. Okay, and if it reads a integer, it will print that integer, and if you have supplied 0, then it will break the loop. So let us try to execute it. I will say 4, no problem. Okay, minus 6, no problem. If I say 5.6, what does it do? It will print 5. Then it continued, it said type in an integer, but decimal point was there in the buffer. It says get care that buffer goes out. Okay, and it does not wait for us to type in anything. It assumes it was typed, so it removes that dot, continues, type in an integer, and 6 was there. So 5.6 will be treated as if we have typed 5 followed by then enter, then decimal point, then enter, then 6, then enter. It is behaving like that. So 5 treated as an integer, dot skipped, then 6 would be treated as an integer, though we have typed a real number, that is floating point number. So here is the use of continue. So it printed this and this one. So it has not entered into an infinite loop. Now if I type some SDF 3 times, it has said type in an integer, type in an integer, type in an integer. It is waiting for me to type in something. Now I will say 5, it says type in an integer, and 0, it comes out of it. So this is the way we can avoid entering into an infinite loop. Okay, this is an infinite loop, but while reading, it may so happen, the situation may so happen that if you have not written your code properly, then you may end up executing a for loop a infinite number of times. Now another one is the for loop. 2-3 things I have demonstrated here. This is a slightly bigger program. So for, and you see here some properties. You can have more than one statements. So here I have written int I equal to 0, initialization, no problem. I less than 5. Then it is not essential that I have to use increment decrement operators or statements. I have said printf okay, comma, printf %d \n I. So this comma here acts as an end. It means execute this also and this also. So it will execute these two. Both the printf will be executed. And then there is a single I plus plus. So I am incrementing I loop variable here. So this statement, set of statement would be executed 5 times itself. Okay. So now you can see here, it has printed okay. Then because value of I is 0, I is less than 5, yes. So it will increment it I plus plus. Then it will say printf okay, printf okay, immediately followed by printf value of I, which is 1 now, and then new line. So it has printed 5 times, 1, 2, 3, 4, 5. Okay. Here, after this, if I say printf %d \n I, if I want to print the value of I, it will say syntax error. It will not compile at all because I is outside the scope of this for loop. Okay. Now, next line of code is int I. Before this for loop, I have declared an integer variable I. Initialize here I equal to 0, and here I am using one more statement. So 2 statements. So here also this comma acts as an end operator. So this is before first semicolon of the for loop. So I can write it like this also. Here I am printing the value of I. Then here this is the test expression, and again the same 2 statements. I am not using increment or decrement, and again I plus plus. Now see for yourself the result. It enters. Initialization is done only once. So printf enter space value of I is 0. So this is printed only once. Now you can see here. This enter space 0 is printed only once, followed by number of times. So this is enter 0, okay 1, okay 2, okay 3, and so on. Okay. So I want to say is before first semicolon in the loop head, you can have more than one statements which can be executed. One of them may be initialization. Another can be any statement which is legal here. Okay. Now, float. This is interesting. Float f, not necessary that you have to have integer here. Not necessary that you can write only I plus plus kind of thing or printf. F plus equal to 0.3. So how many times this is supposed to execute? 0.3, 0.6, 0.9, 1.2, 4 times. Okay, but see here, it has printed the value 3 times, 0.3, 0.6 next iteration, and 0.9, whereas it is less than equal to. Okay, how to know this is just to create space here, I have extra printf. Now here you can see here, I have set again initialize f to 0.3, f less than equal to 1.2, f plus equal to 0.3. So I am incrementing f every time 0.3 times by 3 is 0.3. But now I am asking it to print 8 digits after decimal point. Now you can see the difference. Here first value is not 0.3, it is 0.3 followed by so many zeros and 1. It is greater than 0.3. Next iteration it becomes 0.6, few zeros and 2. It means it is greater than 0.6. Third time it becomes 0.9 and few zeros followed by 4. It means it is greater than 0.9. It is not 0.9. So next time naturally when you add 0.3 to it, it means actually you are adding this 0.30000001 to this value, which would be definitely greater than 1.2, and hence it is printing only 3 times, not 4 times. What is the reason? Reason is the reason being that not every real number can be represented exactly in floating point representation 754, IEEE 754, which I have talked about number of times. Okay, so if this is the situation, you have to be very careful how the values of the loop variable are being generated. Okay, so we just saw the working programs. Next, in the next video, we will study while and do while loops. While it is a single while loop, but it can be written in another form, do while loop. So in this video, we have studied for loops. In the next video, we will study while loops. That is all in this video. Thanks for watching.